seen him. I lost like
my grandmother.
I never looked back.
Everybody loved that.
He was
feature.
randomly talking to one like
It was like the neatest feature. So with this, actually, it's not my mouse off there. Yep. So with this computer, it's actually not a touch screen. It looks like a touch screen. That's like a touch screen. So what it's doing is actually recognizes images and recognizes things. Thank you. And it recognizes the difference between images. So, and what it does is it introduces a whole new world of collaboration. So before I would sit up here and I'd sit here and show you these things. Now we can all gather around and I can actually put my hands down. It can recognize not just 1 point or 2 points. That's like an iPhone, right? You can actually recognize 5 points or 10 points. Go ahead and put your hands on. Put your hands on. 10 points, 15 points. It can recognize up to 50 points, and now we can all move and play with it. You can move it around. It introduces a whole new level of interactivity and collaboration.
How many cameras did you say? 5?
So it has 6 optical cameras underneath. And I'll show you how the optical cameras work in 1 second. So why is this important? First of all, collaboration. Second of all, is recognition. If it was a touch screen, it wouldn't know the difference between my finger and your finger, right? I put anything on it, it wouldn't know the difference. This one actually does. Watch how this works. So what we did is we wrote a real short, quick physics engine here. And what this thing tells is that send balls from point A to point B, unless you're interrupting. Go ahead and interrupt it. Put your hand on it. Go interrupt it. All right, you can see it doesn't just work for anything. It actually is looking for a specific object. That doesn't work. This gentleman's hand doesn't work either. No, it doesn't interrupt. See, if it was a touch screen, we could just interrupt it. It's actually looking for objects. So check these little guys out. If you take these through airport security, by the way, they pull them out every single time. It's really hard to explain what this is, by the way. I'm not kidding. It's a true story. DCA to San Francisco, they pull them out. Bag check. First question she asks is it dangerous? So, but check this out. It's got a Microsoft Surface tag on it. Acts like a barcode. So it does 2 things. It allows it to recognize what this object is. So you can code this, have a database call. It also, because of the orientation, allows you to show the direction that it's pointing in, which is important for a knob, and I'll show you why. It doesn't work for my hand, but watch, it recognizes the object. You can actually see the dot over here. So these people probably can't see it, but you see the dot right there? It actually can tell, you can tell which direction it's pointing, this direction, it's pointing towards you guys over here now. Why is that important? It's important because then you can actually interact with the environments, and we can actually turn the knob and interact with the environment. You don't see that every day, do you? Wow. It's like, are you kidding me? When our guy showed me this, I was like, what? We can do this nowadays? So look, we can actually interact with our environment, do a little time-space continuum here. If you can think of practical applications, architecture, wind flow, floodwaters, drainage, these little guys can be buffalo, they can be cars. We could have done this as a traffic pattern. I just kept it as simple as possible for the purpose of demonstration. So we can move these guys all around and it actually reacts to the environment. So we introduced a couple things. Backtrack, make sure everybody's on pace here. We introduced collaborative computing, multiple people, multiple times, all touching the computer at the same time. Get everybody around the room. Object recognition. Another thing we introduced here is we're also introduced the property of weight. You don't see this every day. You see it sometimes in video games, but the fact that objects actually have weight to them. See these little guys here? Very little weight to him. Man, I throw that little guy and he bounces all over the place. And these little guys, they bounce all over the place. So these are little 1 and 2 pixel images. This is a 50 megabyte video file, so we introduced the property of weight. It reacts totally different than those. I try to throw it and it thuds. Because it's bigger, it's heavier. So we introduced the properties of weight. We also introduce calculations on the fly. This goes a little bit away from things, but I like to show this. Anybody know what Voronoi diagrams are? You guys ever heard of Voronoi diagrams? Any math people around here? Any physics guys? So Voronoi diagrams are used a lot in robotics. So for instance, when a robot wants to go from point A to point B, let's just say this is my little robot here, wants to go from point A to say point B, it has to figure out the path of least resistance. The path of least resistance right now is a straight line, correct? Okay, so if I put objects in its way, then it has to find a way around those objects. So it actually uses math to dissect the midpoints. And so it finds its way, doom, doom, here. Stay away from path of least resistance. Everybody's got that? Whoops. So watch this. Using multi-touch, we can do all of this on the fly. We have the streets of Baghdad. We can also, whoops. We can also take Austin, Texas. I think Baghdad's a little bit more dangerous. We pick points, add points, and on the fly, it does the computations for Voronoi diagrams. This is a little bit different than the other stuff, but I always like to show this real quick. It shows off the horsepower of this Microsoft box. These are highly computational and they take forever to render usually, but this is actually doing everything on the fly. All right, cool. So you guys say, Sean, that's all well and good. We've done, let's go back real quick. Collaborative computing, multiple people, multiple touch points, up to 50 touch points. Recognizes objects, interaction with the environments, and weight as well. We don't need to go back to weight. I think everybody understands that. So check this out. So what I said to our guys is let's do a little bit of a real world example, something that we can collaborate on. Everybody plays music, right? If I give you the CD, you can play this. I played this CD about 1,000 times in my lifetime. I'm getting a little bit tired of the CD, but I do really like the CD, and I like the genre of music. It's pretty cool. I like it. I want to explore this. What we want to do is we want to introduce collaborative computing. So we want multiple people, you and I are all sitting around, we're hanging out at my place or some bar, and we want to introduce the fact that I bring this CD and I want to hear music that's similar to it. I have a Microsoft Surface tag on it, so I tag it, basically give it a barcode, I give it a way to recognize it. And I use this application. This is 3 guys at Synergy. This is our research and development division. This is 3 guys, a lot of Red Bull over the course of 3 days on a weekend did this. It ties in, you guys know what Last.fm is, the music service? All right, so people that are familiar with Last.fm, it's a great way to learn about music. So what this thing does, hey, that gentleman's from yesterday. So Last.fm allows you to go out and pull the music and find like-minded music. So I don't want to play this Outkast CD. I played it 1,000 times. What I wanted to do is recognize this CD. Recognizes the CD, knows that it's Outkast, goes to the Last.fm music service, and then it goes out and it pulls similar music. So lets me pick up the CD, engages a music player that we wrote, goes out, streams it from the web. This is all real time, nothing's mocked up here, and it finds similar music to the Outkast, and it plays it for us. And then what it does is it goes out and finds 10 more artists and songs that are similar, and it allows you to sit there all night long, engaging with one CD, and never hear the same music twice. Totally different. And then we can also collaborate. So I can say, hey man, check this out, check out Nas, check out Common. And you can say, oh hey, I want to try out Common. So we put on Common, and it'll go find music similar to Common. Once again, we don't want to play Common, we want music similar to Common. Finds out J Dilla, pulls me 10 more artists like it. And we can continue to explore. Some Microsoft guys on the other side. They take checks, I think. These are for sale. They're being used in retail applications right now. You'll find